Hello everyone, welcome to the control system. This is part 2 of lecture 7 on transient response and steady state analysis. So in this section we'll discuss the first order system. So consider the first order system shown below, which is this one, 1 over Ts, because this S and then powered by 1. So this is the first order system. This is the simple first order system. Rs is the input, reference input. Cs is the response. And from the lecture file and block diagram, you can do the manipulation, combine this block together, and then it will result in this. Okay, they are equivalent. This is a complex form. 1 over Ts plus 1. So the output and the input-output relation will be given like this. Cs over Rs equal 1 over Ts plus 1. And later we'll use the inputs, the unit step input, the unit ramp, and unit impulse functions to analyze the response. And this Rs will be replaced by this and this. And we have to assume that the initial conditions are 0. Okay, let's consider the unit step response. So since the Laplace transform of the unit step functions is 1 over s, you can just substitute this Rs equal 1 over s into the previous equation, and you will obtain this Cs like this. Okay, and we need to do partial fractions. So if you don't remember partial fraction, please go back to lecture 2. So after doing the partial fraction, you will obtain the Cs given by this. Okay, and then you can take the inverse Laplace transform and then transform from S domain to T domain. So Cs can be found like this, where T is larger than or equal to 0. So if you substitute T equal to 0 into Ct, and then Ct will just 0. So this term will go to 0, will go to 1, and then 1 minus 1 equals 0. So when T equals capital T, so Ct equals 0.6332. Okay, so the response Ct reached 63.2% of its total change. And this is Ct, the graph of Ct equal 1 minus e powered by minus t over capital T. And at t equal to 0, this is the slope, okay? 1 over t. So as you can see from the graph, that the smaller the time constant t, the smaller the time constant t, and you can see this is faster, the faster the system responds. And the slope of the curve, Ct decrease monotonically. So this is large, and then it decreases monotonically until at this times it's almost 0. So t is getting larger and larger. Well, if t equal infinity, and then the slope will be 0. Well, there's no such thing called infinity, but yeah, when time is large enough, this slope will be 0. So in practice, a reasonable estimate of the response time is the length of the time the response curve need to reach and stay within 2%. So around this within 2%. Okay, next we'll consider the unit ramp response of the first order system. Well, since the Laplace transform of the unit ramp function is 1 over s squared, and substitute this into the transfer function, we obtain the output of the system given by these equations. And then again, we do partial fraction. Well, I'm not going to teach you how to do partial fraction again because we did it in lecture 2. So you can just go back if needed. So CS will be obtained like this. Okay, and then you want to transform from S domain to time domain. So you need to take the inverse Laplace transform. So now we obtain CT in time domain given by this. And if you want to find the error signal, the error signal is just the reference signal minus the response. So if you do the math, you will obtain the errors like this. So from this equation, what equation tell us? So this is the response. CT, this one, and this is RT. RT equal T, it's a RAM input, and then this is the response. So there will always a steady state errors, no matter what. So as t approach infinity, when t is large enough, this term e minus t over capital T will go to 0, and then there will only t. So the error signal, this term is gone, so et will be equal only t. Okay, so e infinity equal to t. So there will always a steady state errors. The steady state errors always exist. Okay, sorry for the English. Okay, and then the smaller the time constant t, the smaller the steady state errors in the following RAM input. Okay. Next, we'll consider the unit impulse response of the first order system. So for the unit impulse input or s equal 1, the outputs of the system can be obtained like this by substitute or s equal 1 in the transfer functions, and then t can be found. So this basically means that as t approach infinity, this term will go to 0. Okay, it is very obvious. And yeah, it has been shown that the response of the unit ramp, unit step, and unit impulse are given like this. Okay, and it can also be seen that the response to the derivative of the input signal can be obtained by differentiating the response of the system to the original signal. So, and it also holds for the integral of the original signal as well. And note that this is a property of linear time invariant system. It means LTI system. For linear time varying system and nonlinear system, you won't have this kinds of property. This property. So LTI, this is not a linear time varying system, and nonlinear system do not possess this property. Okay. Thank you for watching this video.